Alright, this video is for lesson 2.2 homework. All we're doing today is function or not a function. So this should be a review from last year. Oh, crooked. There we go. Alright, if it's a function, the x doesn't repeat with a different y. The x can repeat if it's paired up with the same y. But if it's paired up with a different y, then it's not a function. So all you need to do is look at your x's. So on this first one, we've got ordered pairs. So ordered pairs always, x comes first, then y. So we've got a -2, a -1, a 0, a 1, and a +2. All those numbers are different, so it's a function. I could add 0, 1 to the end of this list, and it's still a function. So the x repeats, 0 and 0, but it repeats with the same y. It's if that y changes. If I put 0, 2 at the end, then it's not a function anymore because the y changed. But that throws a lot of kids off. They'll see that x repeat and they don't go to check the y. Tables is the same way. Look at your x's. -5, -4, -3, 0, -3, but I want to check the y's. Y's stay the same. -4 repeats, but the y stays the same. -5 repeats, but the y stays the same. It's still a function. As long as that y doesn't change, you're still good.
What's the y that can't change? X can't change or y?
If you have an x that repeats, like this, -5 and -5, it has to be paired up with the same y. What about this one? What about number 4? Function or not a function? Function. Y can repeat. That's fine. Nothing says the y can't repeat as long as this x doesn't. All right, when you have a graph, we do the vertical line test. If it's dots, you need to draw a vertical line through every dot. And well, you can draw a line through every dot, but if you have 2 dots on the same line, like that one, that's not a function. And you've got to be able to move that line. Okay, you've got to be able to put that vertical line anywhere on the graph. Because you could say, well, if I draw the vertical line here, it only goes through 1 dot. Doesn't matter. I've got to be able to do it anywhere on that graph. Okay, equations. We graph them. So I'm actually going to do this one because this one's a little bit tougher to graph. So let me get my calculator up really quick. Okay, so for this one, I'm going to go to the graphing. So square roots on your calculator, you have to type in twice because every square root has a positive and a negative answer. So I'm going to do the square root of 3x minus 2, and then I'm going to come down and I'm going to do the negative square root. So I'm going to do both the positive and the negative. And I'm going to graph it. If I draw a vertical line on that graph, is it going to touch the function in 2 places? Yes. If I draw a vertical line here, it's going to touch the blue and the red. So that one's not a function. And so if they give you an equation, you can graph it and look at it.
Wait, what? So I got this one, but what did I do on this one?
How did I, with the second one? You're going to have to show me your calculator. That's the only way I can tell you. You put the negative in here. The negative should be outside. That's what it looks like. You actually used a negative instead of a subtraction sign too. So this should be minus and then a negative out front here.
Oh, okay. Thank you.
Yep. All right. Word problems. Number 9. Temperature is measured every minute over a time period for 1 hour. So think about what the graph would look like. So time is typically always x. And then the temperature is going to be the y. So say I do it every minute. So minute 1, 2, 3, 4, 5. If I take the temperature at minute 1, am I going to get more than one answer? No. If I take the temperature at a specific time, I'm going to get one answer. It's 70 degrees outside. And then at minute 2, maybe it's 71 degrees. And then at minute 3, it's still 71 degrees. So with time as your x, you're only going to have one output value, or one y, for each x value. Word problems are the hardest. So number 10, data is collected on the time it takes students to get to school and the distance they live from school. So do I have anybody that walks? Okay. So we're going to say Stephen, and he walks. And Stephen, we're just going to say, ooh, if I could spell, I walked. He walks 1 mile. Okay? Do I have anybody that rides the bus? Okay? So Gracie rides the bus. And let's say she lives 1 mile from the school. Anybody, I guess the rest of y'all parents drop you off or siblings bring you, right? So I'm just going to use Lila. And I know you live further than 1 mile. But Lila drives and she lives 1 mile. Is it going to take the same amount of time for these 3 people to get to school? No. No. Even though they live the same distance, Lila's probably going to be the fastest. And then Stephen. And then Gracie, because that school bus, I know, goes all over the place. So in a situation like this where I can have X's, so people be the same distance from the school, their output, the time it takes them to get to school, would be different. So maybe it takes Stephen 5 minutes, takes Lila 1 minute, but it takes Gracie 20 minutes. So all the same X's, each with a different Y. So that one's not a function. So that leaves you 3. That's all I'm asking of you today. 3 on your own, and then I'm done with you.